Precision concrete scanning and imaging are at the heart of GPRS. We've been leading the concrete scanning industry with ground penetrating radar and electromagnetic imaging since 2001. So it's easy to think that when it comes to concrete slabs and rebar, we've seen it all. But when area manager Jamie Gamache discovered something mind-boggling while scanning a building in Watertown, Massachusetts, we were reminded that innovation is driven by necessity and can change the scope of history. In 2020, Gamache was called in to assess the concrete floors of a pre-World War I munitions factory, which was being renovated into a healthcare facility. Our client needed to be certain that the 100-year-old concrete was strong enough to bear the heavy medical equipment that they were planning on installing. It turns out the concrete was more than up for the job. The cannon factory was part of the Watertown arsenal, one of the first major munitions and manufacturing facilities created by the fledgling US government all the way back in 1814. The specific building in question, Building 311, needed to be able to withstand the construction and storage of heavy munitions like carriages for 16-inch Seacoast guns, and disappearing barbette and railway carriages during World War I. But neither Gamache nor our client were aware of this. When Gamache began scanning the building, he found what he described as putting together a puzzle when you can't see any of the pieces. What was originally supposed to be a quick scan of a 40 by 40 area turned into a 4-day marathon to achieve an accurate measurement of a 20 by 20 area. Once the pattern was established, there was no need to keep scanning because it was clear the concrete slab could hold nearly anything the new owners might throw at it. The incredible rebar pattern embedded in the nearly 12-inch thick concrete slab was unlike anything anyone at GPRS had ever encountered. It was an extremely rare example of a circumferential design, also known as the SMI system of a flat slab construction. It's also sometimes referred to as the spider web pattern, and combines concentric circles and straight rebar running through them in a starburst pattern. The SMI system was developed by Edward Smolsky, a New York City engineer who patented his rebar pattern in 1916. It likely fell out of favor because bent rebar is more expensive and complicated to produce, and almost impossible to remove from the slab when demoing. The onset of World War II also played a part in the spiderweb pattern's demise, as the additional metals to produce it were needed more for munitions than for homeland construction projects. If Gamache hadn't been dedicated to solving the puzzle of Building 311, our client would have likely cut into a whole lot of rebar, causing extensive and expensive damage to the building and their equipment, and endangering the lives of their work crews. Keeping projects on time, on budget, and safe, that's intelligently visualizing the built world.